OTC, CL212.
Go ahead.
Okay, I can give you 725.
Copy that. CDR OTC, air to ground 1.
CDR, go ahead.
Okay, we can perform our cabin vent redundancy configure this time. On panel L2A1.
Roger.
Vent isole switch closed until the vent isole talkback shows closed.
That's complete.
And the vent switch open until the vent talkback shows open.
That's complete.
All right, copy. ECL OTC.
Go ahead.
Yeah, 746.
Copy. Okay, we're going to monitor that for a few more minutes.
Okay.
OTC, CL 212.
Go ahead.
Okay, we can give you step 746 this time.
Okay. How about 747?
Okay, it'll be 0.008.
HCD OTC. This is HCD. Go ahead. You ready for the cabin vent? Oh, that's affirmed. Copy that. CDR OTC, air to ground.
Go ahead.
You want to open the cabin vent isole valve, and the klaxon and master alarms may occur in the next step.
Roger.
Panel L2A1, the vent isole switch open until the vent isole talkback shows open.
That's complete. And we have the klaxon.
And ECL.
I can verify step 751.
And CDR, verify.
This is shuttle launch control at T-minus 36 minutes and counting.
That's affirmative. It is decreasing.
The SRO, which is the Superintendent of Range Operations, has just informed the NASA Test Director that the range is ready for launch, meaning that the downrange shipping lanes are clear, that the booster splashdown area is clear, and that all of the Air Force Eastern Test Range downrange tracking stations are up and ready to support. The ground launch sequencer mainline computer program has been activated and is now actually processing data. This program will monitor various key commands and systems prior to assuming control of the countdown at the T-minus 9-minute and counting mark. The shuttle weather officer in the Cape Canaveral forecast facility will be giving Launch Director Bob Seek a briefing at the T-minus 25-minute mark in about 10 minutes. We've received word that the latest wind balloon, the Gymsphere, has completed its run at 56,700 feet, and that data is now being processed. Much of the activity over the last week has been associated with changing out Discovery's #1 auxiliary power unit, which was removed last Saturday and sent back to the vendor for analysis. A new one was on hand and ready for installation, and we have video of that unit being prepared for transportation to the launch pad.
Discovery Houston, SIMO air-to-ground voice checks, Eddie Reed.
The auxiliary power unit, which presented the problem, was found to
Roger that, MS's 1, 2, and 3.
have a chip in one of the valves that's involved with regulating the flow of hydrazine. Therefore, what we found was a one-time hardware problem
MS3.
and not an overall design or engineering concern. This is the replacement auxiliary power unit being prepared for transportation. In the back, there is the one that was taken out and was shipped back to the vendor for analysis.
Altimeter setting of 30.
That is the aft area of Discovery where the replacement auxiliary power unit will be installed, and adjacent is the external tank and the solid rocket boosters.
What we're working, Banjul right now is a single string for TACANs.
The replacement
We're planning on going
unit was transported to the pad on Saturday and was connected
possibility of a 3000
on Sunday. Most of that work was completed in time to give most of the
basically all 3 TACANs.
team the rest of the Easter Sunday period off.
Primary TACAN back up again. We may yet declare Banjul.
After the installation, the replacement auxiliary power unit
AOA.
was hot-fired, was run for a little over 5 minutes to verify that there
Our primary
would not be a repeat of the problem that we had before,
we have
and to give it the same amount of runtime as the other auxiliary power units which are on board Discovery. And that test went fine.
Okay, Steve, we copy.
NCDR OTC, air-to-ground 1.
This now is going into the aft area for the installation. In parallel with this activity, the payload bay doors of Discovery were closed and the batteries for the Hubble Space Telescope were back in the battery lab being charged. This procedure had not been done vertically before. It had been done in the hangars, so that procedure was modified with some contingency time built in to allow for any problems should they be encountered, this being a new approach. However, the change out and the retest went very well. Most of that contingency time was not used, and with the Hubble battery charging getting started a little bit earlier, then all things came together to make it possible to move up our launch date from the 25th to the 24th.
and that's to Northrop 23.
We're now at T-minus 31 minutes 50, T-minus 30 minutes 55 seconds and counting, leading toward an 8:31 a.m. liftoff this morning. This is Shuttle Launch Control.
TWS OTC.
Double F, good.
Can you verify anything on your CRTs? G and 2 press.
Yeah, they're verified.
Copy. ahead. Okay, you want to pick up 774, please? 774 through 778 are complete. Copy that. OTC, CSL. Go ahead. Yes, sir, step 787 is complete. Copy. OTC, CSL. Go ahead. 768 complete. Copy. LVCC, OTC. ISL, OTC. Sorry, go ahead. Are you ready for the next pre-flight bites? Yes, sir, I am. EPD. EPD copy. OTC, EPD. Go ahead. I can give you step 790. Okay. CLS, OTC. CLS 212. Yeah, you want to pick up 791 by the clock, please. Copy, 791 by the clock.
OTC, CL212.
Go ahead.
I can give you step 807.
Copy that. CDR, OTC, air to ground 1.
CDR, go ahead.
Can you report your cabin press at this time, please?
The gauge looks like about 14.8.
Copy that. ACL.
Okay, on 809, I have 14.82.
Okay, CDR on the CRT3. ESS system page 1. Report your cabin press, please.
And OTC CDR cabin press is 14.7 on the CRT.
Copy that. And CDR, at this time, you can close your cabin vent valves.
It's in work. OTC CDR, both the vent ISO and vent are closed.
Copy that, ACL.
And I can give you 814.
Copy. PVD, OTC.
This PVD, go ahead.
We're going to be performing steps 821 through 23.
Negative, will be all not performed.
AFM, OTC. AFM, go ahead. You can do your start check or door open indication status check at this time. It worked. countdown clock will hold at T-minus 20 minutes in approximately 4 minutes. OTC AFM. Go ahead. Can you give you step 831? Copy. All operator systems on channel 212. Verify your program software and report only if any discrepancies. CVFS OTC.
CVFS.
And RAS number for me on 827.
That's 031.41.
Thank you. ARPS OTC. ARPS OTC channel 212. ARPS? Yeah, you want to pick up step 838, change the MTU test set to delay 0? That's complete. Thank you. EPS OTC.
Yes.
Can you verify 2 consecutive OC task concurrencies available?
That's verified.
Thank you.
This is shuttle launch control at T-minus 20 minutes, 30 seconds, and counting. We are preparing now to enter the T-minus 20-minute built-in hold. This hold will last for 10 minutes. During this period, the NASA test director will ask members of the launch team to verify that the proper software has been loaded aboard for the remainder of the countdown, and we'll get verification that the pre-flight inertial measurement unit alignment has been completed. Going into the hold now in 3, 2, 1, T-minus 20 minutes and holding for 10 minutes. The landing and recovery director has reported that the shuttle landing facility is ready and configured for launch and has verified that the booster recovery ships are on station and ready to support. The NASA test director is about to brief the launch team on recycle options during the remainder of the countdown. From now until T-minus 31 seconds, any of the console operators can ask that the countdown be held if a problem is detected. After T-minus 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle back to the T-minus 20-minute mark. The launch director has just been given an update on the weather. We continue to see mostly scattered clouds offshore, gradually moving onshore, and they are not expected to be a constraint. As they move onshore and into the area, they are being evaluated by Dan Brandenstein in the shuttle training aircraft as he makes approaches to the shuttle landing facility. Overseas, Banjul weather is acceptable, reporting clouds 12,000 scattered, 20,000 thin broken, visibility 6, and northeasterly winds 10 to 15.
KVFX active on 212. HTD.
Here at KSC, our winds running mostly from the east at 10 to 12, and the status board at the Cape Canaveral forecast facility reflecting shuttle weather constraints is all green at this time. At T-minus 20 minutes and holding, this is shuttle launch control.
SRO NTD 212. SRO NTD 212. NTD, this is GOS. I see him coming in weak. We're working the following. Copy. NTD CGLS on 212. Go ahead, Joe. Yes, sir. The countdown clock will start at 12:01 GMT. Copy. OTC PD. Go ahead. Did I get a CMQC on 151? CMQC OTC. The CMQC, go ahead. Yeah, EPD OTC. Go ahead. What are you doing? Either for the fuel cell load sharing adjust. Okay. Yeah, 151 QC. Stop looking at it. Copy.
OTC CFCP.
Go ahead.
Yeah, can we get a CMQC on 153?
Same thing?
That's front for our purge.
Okay. CMQC. Copy 153. OTC, Seattle. Go ahead. Yes, sir. We also need a CMQC on 145 for our recorder activation later on. CMQC. Copy 145. SRO NTD 212. NTD RSO, read you loud and clear on 212. 212. RSO NTD 212. NTD RSO NTD, do you copy on 212? OTC TP. Go ahead. Passing to COOS on 161. COOS OTC.
Yeah, go ahead.
Yeah, can you go 161 with TPE, please?
Yeah, going 161.
NTD safety 212. Go ahead, sir. Yes, sir. I can give you step 966, close out crew at AB11. Have you got any words on step 798? STM NTD. STM NTD 212. STM, go ahead. You have a verification of 798. We've got the CCF clear. We're still waiting on the LDA. Copy. This is NTD on 212 and 232 conducting the T-minus 20-minute briefing. The launch window opens at 12:31 GMT and closes at 18:43 GMT. A second launch attempt is possible if a recycle occurs. There are 3 COLAs for today. COLA 1 opens at 12:58:30 GMT and closes at 12:59:30 GMT. COLA 2 starts at 14:32 GMT and ends at 14:37:30 GMT. COLA number 3 opens at 16:12 GMT and closes at 16:13 GMT. start upon command of OTC only.
CLT copies.
CDR, the pad egress system is nominal and the evacuation helipad is 8.
Okay, we copy 8. Thank you.
Fine room launch team, disable telephone ringers at this time. Ingress and egress of the fine room will not be allowed after resuming the count at T-minus 20 minutes until after launch or flight crew egress if a recycle occurs. If an extended hold is required at T-minus 9 minutes, limited fine room access will be allowed. All personnel bear in mind that critical post-launch operations will be in progress after a successful launch, so keep fine room activities and noise to a minimum. Are there any questions? That concludes the briefing. Flight NTD. Houston Flight NTD 212. Houston Flight NTD air to ground 1.
Okay, NTD Flight 212.
Okay, step 897A, you can proceed with transmission of your variable ascent parameters.
Hey, welcome.
And flight, can you verify that you're ready?
Correct, sir.
Houston Flight NTD.
This flight go.
Step 898, can you verify ready to resume the count at 20 minutes?
Okay, stand by 1 second, NTD. NTD Flight is go.
Understand. The countdown clock will start at T-minus 20 minutes in 2 minutes.
OTC CTNC, go. I can report step 897. IMU pre-flight alignment is complete. Ready for transition to OPS 1. OPS transition must occur within 10 minutes. Your GMT time there is 11:58. 11:58, copy. And I can also report completion on steps 899 and 900. Copy that.
NTD copy.
NTD STM 212.
Go ahead, STM.
Okay, step 794, 798, and 819 complete.
798 and 819, is that affirmed?
That's correct, and also 794.
Copy.
All personnel on channel 212 this OTC. After transition to OPS 101, discontinue all LDB PMU reads for remainder of count.
Safety console NTD. Safety console 798 is complete. Copy.
This is shuttle launch control at T-minus 20 minutes and holding. We are just about 1 minute away from taking up the countdown at the T-minus 20 minute mark.
Yeah, CMQC.
As we come out of the hold, Discovery's onboard computers will transition into the terminal countdown configuration, and we will dump the computer memory of one of the 4 primary computers so that we can look at the data and make sure that the OPS 101 program, which is the primary program, has been stored properly and that there are no unexpected results.
Copy that.
Taking up the count now in about 20 seconds.
I copy that. Safety 966 also.
Again, we're still aiming toward an 8:31 a.m. liftoff. We have no constraints with the shuttle or weatherwise. Picking up now in 5, 4, 3, 2, 1. T-minus 20 minutes and counting.
SCP OTC.
Purge of Discovery's 3 fuel cells is now underway. The data processing system engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration.
Loud and clear, I copy.
We do have 3 COLAs today during the period, which extends from 8:31 to 2:43. There would be a collision avoidance quotient that would begin at 8:58:30 this morning and run for 1 minute. There would be another one at 10:32 this morning, which would last for 5.5 minutes, and another one at 12:12 this afternoon, which would last for 1 minute. That last one, however, would be academic in light of the fact that the crew time in the cockpit of Discovery would expire at 11 a.m. All activity continues on schedule as we proceed toward the next hold at T-minus 9 minutes. The primary ascent software is now in the Ops 101 mode, which is the primary launch program, and Commander Schreiber will now configure the backup flight system computer to match that configuration. T-minus 18 minutes, 20 seconds and counting.
NTD STM 212. Go ahead, STM. Step 916, will that be performed or not performed, sir? That's not performed. Copy.
OTC, CDR, and PFS is an Ops 1, no unexpected messages.
Copy that, thank you. And PLT, OTC.
Go ahead, Sam.
Okay, configure pass and BFS horizontal sit displays per your checklist, please.
Commander Schreiber has reported that the backup flight system is now in the proper mode, and we just saw astronaut Dan Brandenstein flying the shuttle training aircraft, doing the weather reconnaissance and assessing the conditions at the shuttle landing facility in the event of a return to launch site abort. He's reporting that data to support astronaut Ken Reichler and astronaut Jim Weatherby here in the firing room. T-minus 17 minutes and counting.
Go ahead.
The BFS pre-flight uplink load is complete.
Copy. CVFS.
CVFS copies.
Dumping of the Ops 101 program stored in the memory of one of the 4 redundant general purpose computers is now underway. That will take about 7 minutes to complete. Engineers will be examining that data for anything that would miscompare.
Go ahead, PLT.
Okay, horizontal fit. Yeah, Stan, horizontal fit config is complete, and we verified the OHM's interconnect config is also verified.
Okay, copy that.
Pilot Charlie Bolden has been in the process of configuring the cockpit switches for launch, and he's reporting that most of that configuration is complete. The airframe engineer is checking all of the critical movable aerosurface driver currents and is positioning all the hydraulic systems for activation.
NTD SRO, go ahead, sir.
969, KFC area is clear for launch.
Roger, copy.
OTC, PLT, MPS helium reconfig is complete.
Copy that. NPS, OTC.
STS, go.
Okay, you verify 945, 946,
Verified.
and 47?
Yeah, yes, sir.
Copy that. Double OS.
Go ahead.
Okay, configuring OHM's RCS cross feed for flight.
At this time, yes.
Copy.
Pilot Charlie Bolden has reported that the helium system reconfiguration has been completed. This opens helium isolation valves necessary for the in-flight purges of the engines.
Checking, sir.
Water levels in the water spray boilers are now being checked, and they are being verified to be sufficient for the mission. The NASA test director has asked Houston Flight to send their pre-flight uplink command to the orbiter's backup flight system. These loads are sent from the Mila tracking station here at KSC and put the 5th general purpose computer in the proper configuration for launch.
NTD SRO 212.
Go ahead.
Yes, sir. Page 813, step 0965, normal track.
Copy.
Configuration of the cross-feed valves between the orbital maneuvering system and the reaction control system propellant tanks is being performed. The orbiter test conductor has asked pilot Charlie Bolden to report the quantities in the reaction control system propellant tanks. Meanwhile, the booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid rocket boosters prior to their ignition. We're at the point now where all non-essential personnel are being cleared from the launch danger area. The white room has been closed out for flight, and the closeout crew has departed back to the roadblock.
MTD, STM 212. Step 986, sir. Copy. And FCP, OTC, air to ground 1.
FCP.
Yeah, your fuel cell purge complete?
Will be shortly.
Copy. Countdown clock will hold at T-minus 9 minutes and 4 minutes.
OTC, CFCP.
Go ahead.
Our fuel cell purge is complete and we're ready for fuel cell load adjustment.
Okay, EPD and ECL and FCP, adjust your fuel cell loads for the Ds.
EPD copy. FCP copies.
ECL copies. OTC, CVFS.
Go ahead.
T-minus 20 minutes, EPC dump is complete.
Copy that. CMQC, it's 979. Copy 979.
T-minus 12 minutes and counting, we've received word from White Sands that the weather reconnaissance aircraft there has advised that with the wind that they're seeing, there is still ample margin out there to cover any contingency in the event that we should have an abort once around. He has reported his observations to the chairman of the mission management team, Brewster Shaw, and Brewster has determined that weather at White Sands is go for launch. We've also received a verification that all of the contingency support is ready and that the aircraft and emergency teams are on station to support the launch today.
Copy that.
The T-minus 20-minute dump of the orbiter general purpose computer memory has been completed. We have no unexpected errors in that report. Now T-minus 11 minutes and counting.
Load adjust is complete. Copy that. ECL. ECL OTC.
Go ahead.
Yeah, can you agree with fuel cell? EPD?
That's affirmative.
Copy. All personnel on channel 212 is OTC. Discontinue all non-mandatory LDB traffic for remainder of count.
T-minus 10 minutes and counting. About 1 minute now from the last planned built-in hold in the STS-31 launch countdown this morning. The flow rate of the conditioned air fed into the orbiter's payload bay is being reduced and will be verified at about 180 pounds per minute, which is the figure desired for launch. Standing by now to go into the hold at T-minus 9, 3, 2, 1, T-minus 9 minutes and holding for 10 minutes. We will emerge from this hold at 8:22 Eastern Time. When the countdown resumes, the ground launch sequencer will be in control. The master computer program will issue the commands to perform all of the final critical tasks required to put the vehicle in its launch configuration. During that time, it will be monitoring as many as 1,000 different parameters in that last 9 minutes to make sure that they do not fall out of any predetermined limits that the launch team calls red lines. All personnel in firing room 1 have now switched over to the same communications channel, and they will be staying on that through launch.
This is NTD on 212, taking a status check for launch. Say go, no go for launch. OTC? Go. TBC? Go. PTC? Go. LPS? Go. Flight? Houston flight, NTD. Nala? Nala, NTD. STM? STM, let's go. Safety
Would it be legal to call my lady?
Now about 2 minutes into the T-minus 9-minute built-in hold. We'll go now to Mission Control in Houston for a readiness statement, and also to the Space Telescope Operations Control Center at Goddard. They will report their readiness. Going now to Mission Control in Houston.
This is Mission Control Houston. Flight controllers in the Figure 1 room are ready for launch. The flight director for Ascent, Von Dittemore, just polled the room, and all positions reported they will be go for coming out of the T-minus 9-minute hold. One slight change to this morning's plans for launch. Ben Guerrier will be designated as the prime transatlantic landing site with Banjul as backup due to a problem with the primary TACAN system at Banjul. The secondary TACAN system is operational, but since weather is good at both sites, we will be choosing Ben Guerrier as the prime transatlantic landing site this morning. No other systems problems are reported, and all positions in Mission Control are standing by for launch. This is Mission Control Houston. We'll hand over now to Hubble Space Telescope Operations at Goddard.
Thumb wheels, channel 118 X-ray.
This is Hubble Telescope Control Greenbelt. The Director of Orbital Verification, Mike Harrington, has confirmed that all control team positions here at the Space Telescope Operations Control Center in Maryland and the support team at the Huntsville Operations Support Center in Alabama are ready to support today's launch of the Hubble Space Telescope. Approximately 3 hours ago, the crew configured switches aboard the orbiter to provide essential power to 3 telescope systems. The telescope's receivers were powered to ensure that they are warm and on frequency to receive initial commands from the control center following launch. Heaters for the rate sensing units were powered to maintain the gyros at a stable temperature, and power was applied to the fixed head star tracker shutters to ensure that they remain closed during launch. Otherwise, the telescope is essentially powered down in Discovery's cargo bay and ready for launch. Beginning approximately 4.5 hours after launch, controllers here will begin sending commands to systematically activate the telescope systems in preparation for tomorrow's scheduled deployment. Again, all is ready here in the control center at Goddard Space Flight Center, Greenbelt, Maryland, and at the support center at the Marshall Space Flight Center in Huntsville, Alabama, for today's launch of the Hubble Space Telescope. At T-minus 9 minutes and holding, this is Hubble Telescope Control Greenbelt, returning now to the Launch Control Center.
This is Shuttle Launch Control in Firing Room 1 of the Launch Control Center at KSC, where we have approximately 5 minutes remaining in the T-minus 9-minute built-in hold. Several milestones remain between now and launch. As we come out of the hold, the ground launch sequencer will take over control and issue commands for the final critical task and monitor the hundreds of vehicle measurements that are coming in during the final 9 minutes. At T-minus 7 minutes 30 seconds, the orbiter access arm retraction will be performed.
No constrained explained condition.
And at T-minus 5 minutes, pilot Charlie Bolden will start up the orbiter's auxiliary power units.
SMSD as in dog.
A gimbal check of the orbiter's aerosurfaces will occur at T-minus 3 minutes 55 seconds. And switch over to internal power occurs at T-minus 3 minutes 30 seconds. And then the orbiter's main engines will be gimbaled or moved at the T-minus 3 minute 25 second mark. LOX tank pressurization and retraction of the GOX vent hood will start at T-minus 2 minutes 55 seconds, and the liquid hydrogen tank will be pressurized for flight at T-minus 1 minute 57 seconds.
Launch Director, with that, the team is ready to proceed. That's step 1016.
Okay, I'll conduct my poll at this time. Payload Operations Director.
Launch Director, payloads are go.
Copy, Engineering Director.
Engineering is go.
Copy, Safety and Quality Director.
Safety and Quality's go, Bob.
Copy, Cape Weather.
You have no weather launch constraints violated. Launch wind forecast from 09 or 0 degrees at 10 knots.
I copy, Operations Manager.
Bob, we have no constraints and you are go to proceed with the launch.
Copy, thank you, sir. Discovery Launch Director. Air to ground.
Discovery, go ahead.
Okay, well, at the risk of being repetitious, we're here again, and everything looks good. Shuttle, ground systems, and the Hubble, and we believe the universe is still go. So we hope we can get you up there to take a look at it today. Have a good one.
Okay, we sure do. Thank you very much. Looks like it's been a good countdown here.
Yes, sir, and NTD, you have go to proceed.
I understand, thank you. Flight, ISL, RPS, NTD.
This flight.
ISL.
This is ISL.
JRPS. JRPS. Okay, step 1012, you can activate recorders. Copy.
That's DVD OTC.
This DVD, go ahead.
Okay, we have a payload bay purge rate set for launch at this time.
That's the firm we just completed. It's stable at 178.
Copy that.
With it not performed on step 1009.
Copy that.
NTD flight recorders have been activated.
Copy. Countdown clock will start in 2 minutes. ISL, did you copy that recorders are active?
NTD, CNSE.
Go ahead, CNSE.
Yeah, overheard changing tail sights to 118 X-ray.
That's firm. And we're now Ben Greer.
And they changed those front wheels yet?
That's firm.
1 minute and 30 seconds from picking up the countdown at T-minus 9, where we will press on toward the handoff of the ground launch sequencer to Discovery. The onboard computers will then start their own automatic sequence, and the final commands will come at T-minus 10 seconds to provide the concurrence for a go for main engine start. The engine start will occur at T-minus 6.6 seconds and solid rocket booster ignition at T0. The orbiter's computers will issue the commands to start, and the ground launch sequencer will concur. 45 seconds now to picking up the countdown. "30 seconds away from picking up at T-minus 9. Nothing is reported amiss, and we are go for picking up the count in 10 seconds.
Hands on clock will resume on my mark. 5, 4, 3, 2, 1, mark. Your left auto sequence has been initiated.
Now into the final phase of this morning's launch countdown with the initiation of the ground launch sequencer. Standing by now for a request from the orbiter test conductor to Houston Flight to send stored program commands, which are the final update on the antenna alignment.
PLT was that for, OTC was that for the PLT?
That's affirmative. Configure fuel cell central bus source switches, please.
That's in work, Stan.
Thank you.
OTC PLT, essential bus connection is complete.
Copy that, thank you.
Next significant event coming very shortly here with the orbiter crew access arm being retracted away from the vehicle into the launch configuration. This arm can be re-extended in less than half a minute if that's necessary. T-minus 7 minutes, 30 seconds and counting.
CLS's go for orbiter access arm retract.
In about 45 seconds, the orbiter test conductor will give pilot Charlie Bolden a go to perform the auxiliary power unit pre-start. Bolden will configure switches in the cockpit to put the APUs in the ready to start configuration. The APUs will be started at T-minus 5 minutes. Go for APU pre-start will come in about 10 seconds.
You want to start your APU on your trip chart recorders, please. Recorder started. And PLT OTC.
Go ahead.
You can perform your APU pre-start, please.
That's in work.
The APUs provide hydraulic power to the orbiter. Standing by for confirmation that the APU pre-start is complete.
Pre-start's complete. 3 gray talkbacks.
Thank you, Charlie.
Pilot Bolden reporting back that the pre-start operations are complete. T-minus 5 minutes, 30 seconds. Mission Control has transmitted the signal to start the flight recorders. The 2 recorders will collect measurements of the shuttle system's performance during the flight for playback later after the vehicle is in orbit. Coming up on T-minus 5 minutes and counting.
CLS's go for orbiter APU start.
And we have a go for APU start.
APUs, please.
That's in work, Stanley.
And CDR OTC.
Go ahead.
You can reconfigure heaters, please.
Commander Schreiber asked to reconfigure the orbiter heaters. He'll report when that's complete.
Heaters are reconfigured.
Thank you.
The ground launch sequencer has terminated liquid oxygen replenish to the external tank and is now initiating the LOX drain back.
And OTC, PLT, APU start is complete, and
Copy
so
that,
far so
thanks.
good.
There are the good words, 3 APUs in good health. About to start a profile test. Profile test of the orbiter's aero surfaces. The orbiter flight control surfaces are being moved through a pre-programmed pattern, and we'll have a gimbling of the main engines, which will follow. Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. At this point, Discovery is being powered by the onboard fuel cells. T-minus 3 minutes and counting.
Ulysses go for ET-LO2 pressurization.
Go for pressurizing the external tank. All systems are go for launch.
OTC 212.
Go ahead, OTC.
Okay, clear caution and warning memory and verify no unexpected errors.
Okay, we have no caution and warning annunciation, Stan. That's
Okay.
complete.
Thank you, Charlie.
Standing by now. Here is the retraction of the gaseous oxygen vent hood. The gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212. Close and lock your visors and initiate your O2 flow, and you all have a good trip.
Roger that. 10 work.
Ulysses go for ET-LH2 pressurization.
Bringing the LH2 pressurization up to flight levels. 90 seconds away from launch now.
1 minute, 30 seconds.
And the LH2 tank now reported at flight pressure. Both tanks, liquid and oxygen, now ready to flow propellants. Sound suppression water system is now being armed, which will flow water onto the mobile launcher platform at the rate of 900,000 gallons a minute, beginning at T-minus 16 seconds. The heaters on the booster joints are now being turned off. The orbiter computers have positioned the vent doors to the launch configuration. Standing by now for a go for auto sequence start. T-minus 33.
Countdown clock will hold at T-minus 31 seconds due to failure.
We've had a hold. We do not know at this time what the problem is. We'll be standing by for word, but the clock is holding at T-minus 31 seconds due to a system failure.
And NTDSD, it's the LO2 outboard fill and drain valve. NTD is CMPL. Go ahead. It's LCC MTS 8. And PV9 outboard fill and drain closed power is off. It should be on. A recommendation? And NTD, that we're in a no-go situation. We should have our open power, and we do not. Or excuse me, our closed power. FP? And MTS, can we verify that the valve is closed? Negative. We right now show a open position. We cannot verify the valve is closed.
SP, this is MTS.
Go MTS.
We're at LCC reads, we have the closed power on and the open
position off. We can cycle one time and try to pick up the closed position, but we never picked up the closed tower.
Okay, in MPS, we have a message that we were blocked by a prerequisite sequence, GCL 18.
What has happened is the ground launch sequencer would not hand off to the orbiter's computers to complete the count because the liquid oxygen fill and drain valve was showing off when it should be on. An analysis of the problem has begun.
We've been holding 2 minutes.
SDE, this is CMTS. We're going to make an attempt to cursor that valve closed. We've got the prereq set off. If this works, we should be in good shape.
I copy. Proceed.
It work?
We have 7 minutes of runtime available on the auxiliary power units. We've been holding now about 2 minutes and 20 seconds.
NTD, this is CMTS. The valve's closed. We're go.
There's the confirmation that we have successfully
Okay, and you're in the process
recycled.
of configuring the pickup terminal sequence MPS.
That's affirmative, so we're go. We're in good shape.
Okay, you have a go to proceed. GLS, pick up the count immediately.
I copy. Mark. GLS is go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles. Booster officer reports all 3 engines stable at 104% performance.
Discovery, Houston, performance is nominal. And Discovery, 2-engine Ben Guerrier.
The 2-engine Ben Guerrier call means that Discovery could reach the transatlantic abort site at Ben Guerrier on 2 engines if it were necessary.
Copy, nominal performance, 2-engine Ben.
Velocity now 5,000 feet per second. Discovery 60 nautical miles away from the launch site. All systems continuing to perform well aboard Discovery. Velocity now is 6,200 feet per second. Downrange 100 nautical miles. The Environmental Systems Officer reports the FES is operating well. That is the flash evaporator system that provides cooling to Discovery's systems.
Discovery Houston, negative return, press to ATO, select Banjul.
Negative return, press to ATO.
That last call means that Discovery cannot return to the launch site at Kennedy. However, enough energy has been achieved to reach a safe orbit on 2 engines should one shut down. And Discovery could also reach the backup transatlantic abort site at Banjul if that were necessary. All 3 engines are stable at 104%. Auxiliary power units all performing well. Discovery's velocity is 8,400 feet per second at a downrange distance of 175 nautical miles.
Discovery, press to MECO.
Press to MECO.
The press to MECO call signifies that Discovery could make the main engine cutoff targets.
Discovery, Droop Banjul 109.
Droop 109.
And that last call means that Discovery could reach the Banjul transatlantic site on 1 engine at 109%. All 3 engines still looking good. Discovery's velocity 12,000 feet per second. Downrange 290 nautical miles at an altitude of 60 nautical miles. Guidance officer confirms that navigation is good.
Discovery, single engine Banjul 104.
Single engine Banjul 104.
Booster officer reports all 3 engines stable.
Houston, single engine press 104.
The single engine press call means that Discovery could make it to main engine cutoff targets on 1 engine at 104%. Discovery's velocity now 16,000 feet per second at an altitude of 58 nautical miles, downrange 435 nautical miles.
Discovery, late call, single engine press 104.
Roger. Fuel cell pH, we expected.
Discovery Houston, concur, no action on fuel cell pH.
No action is required, no impact on that pH message. That message was expected during this phase of the launch. Velocity now 19,000 feet per second. 3 engines throttling back now to maintain the 3G limits on the vehicle. Discovery is 580 miles away from Kennedy at an altitude of 56 nautical miles. We are standing by for main engine cutoff at 8 minutes 32 seconds mission elapsed time.
Good, Miko. Looks nominal from here.
And the booster officer also confirms a nominal main engine cutoff.
Discovery, we see ET-SEP. Nominal MECO, ohms 1 is not required.
The booster officer has also confirmed.
No ohms 1 required.
This is Mission Control. The booster officer confirms good separation from the external tank, and the flight dynamics officer confirms good performance on both phases of the ascent. No orbital maneuvering systems 1 burn is required.
Discovery Houston, for info, we've had some problems out at White Sands, but we anticipate a nominal handover to Tidris at 11 plus 30.
And Houston, we copy, and we had left L3A tail off during the plus 5 second dump.
Roger that, Discovery. We see it. No action for you now. We're still evaluating.
This is Mission Control. The ground control officer does not expect any loss of communications capability with the crew. We will be handing over to the tracking data relay satellite at about 11.5 minutes mission elapsed time. There have been some minor problems at the White Sands ground station, but they expect no particular impact from that. Booster officer reports that we see data indicating the main propulsion system dump is in progress. This procedure vents any remaining fuel or gases that may have resided in the engines at the end of their burn, just to make sure that those gases are vented out of the system and not present any problems for the remainder of the mission.
Discovery Houston.
Discovery, we're standing by. Go ahead.
Roger that, alarm. We're back with you through TDRS. Expect nominal ohms 2, anticipated delta V, 4, 9, or 5.
Okay, we copy and standing by on your go for APU shutdown.
Roger that, Discovery, stand by. Discovery Houston, go for APU shutdown.
Roger.
This is Mission Control. The crew has received the go to shut down the auxiliary power units. And they've been informed also that the normal orbital maneuvering systems 2 burn will be done on time, which is scheduled for 42 minutes 39 seconds mission elapsed time. Change in velocity will be 495 feet per second, and that burn will put Discovery in an orbit of 330 by 310 nautical miles. This is Mission Control. Mechanical Systems Officer reports that the APU shutdown was normal, that the procedure looked good, and the configuration of the auxiliary power units looks good. This is Mission Control. The MAX officer reports indications that the external tank doors are closing aboard Discovery. Crew is right on time, following through the post-insertion timeline, or the post-ascent checklist, and at about 50 minutes mission elapsed time, just short of an hour, they will begin procedures in the post-insertion timeline. MAX officer confirms that the external tank doors are closed and latched.
Discovery Houston, while you're on the way to Attitude, if you've got a spare moment, we'd appreciate a debris report.
Okay, Steve, stand by one. Houston Discovery, for debris on the way uphill, right in the about from a minute and a half to 2, Charlie and I noticed several flecks of things impacted the forward windscreen. They seem to be pretty soft and just leave little streaks. SRB SEP put a pretty good little cloud on all the windows. And here at vacuum inerting terminate, we see lots of ice particles, but that's all normal. And between SRB SEP and MECO, we didn't really see that much debris that we can recall.
Okay, roger that, Discovery. Appreciate the report.
This is Mission Control. A guidance officer has reported that Discovery has almost completed the maneuver to the position for the Orbital Maneuvering Systems 2 burn. That burn is scheduled about 16 minutes from now at 42 minutes mission elapsed time. And that OMS burn will have a change in velocity of 495 feet per second and will raise the low point of Discovery's orbit to 310 nautical miles.
Discovery Houston, we see you in burn attitude and your targets look good.
Roger that, Houston. Hang on, Houston, Discovery, we see the tank and burn attitude down below us. It looks like it's straight down below us between us and Africa.
Roger that, Lauren. We copy, and about how far away do you think it is?
On the long axis, it would probably be about a 6 or 7 mil radius on the coax.
Roger that. Thank you very much.
is Mission Control. The guidance officer has seen the data indicating that Discovery is in the proper position for the OMS 2 burn. And Commander Lauren Shriver was discussing with Capcom Steve Oswald that the crew could see the external tank below them on its way to the impact area.
And Houston, Discovery, are you still with us?
That's affirmative, Discovery. You're loud and clear.
Okay, as we've been coasting here, we've just been watching the external tank tumble, I don't know, 4 or 5 times since we called you last.
Roger that. Must be a beautiful view. Discovery Houston with some words on your burn.
Go ahead.
Roger, Lawrence, since we lost L3A, if you should lose an engine during the OMS 2 burn, an OMS engine, we want you to terminate the burn at an HP of 85.
Okay, we copy.
This is Mission Control. That last note given to the crew refers to the small reaction control jet number L3A, which failed off shortly after the ascent phase was completed. Propulsion officer thinks that was due to a valve failure, perhaps in the oxygen valve system of that small RCS jet. Therefore, the crew's just been given a little note to change their procedure card. If during the upcoming Orbital Maneuvering Systems 2 burn, they should have an OMS engine failure, they would terminate the burn at an altitude, perigee altitude of 85 nautical miles in order to give flight controllers time to assess the situation and see what action should be taken at that point. We'll be coming up in about 2.5 minutes on the time of ignition for the OMS 2 burn. Once again, that's at 42 minutes, 36 seconds mission elapsed time. Delta velocity for the burn is 495 feet per second. Should raise the perigee of Discovery's orbit, or the low point of Discovery's orbit, to 310 nautical miles, resulting in a final orbit of 330 by 310 nautical miles. This is Mission Control. This is Mission Control. The propulsion officer reports that he sees data indicating that all the systems are in the proper configuration for the burn.
And Houston, Discovery, just information, the telescope remained powered up through ascent. We thought you'd like to know that.
Roger that, Discovery. That's good news. Thanks for the words. And Discovery Houston, your targets look good and your OMS configuration is good for the burn.
Roger that.
This is Mission Control. The propulsion officer reports seeing the OMS 2 burn begin and 2 good engines. Looking good so far.
Discovery Houston, we're going to lose you here in about a minute on the East Tidris. Burn's looking good so far. We'll see you on the west side at 51 minutes MET.
We copy 51 minutes.
This is Mission Control. We've gone out of voice and data contact with the crew through the Tidris East. In about 3.5 minutes, we'll pick up communications again on the Tracking Data Relay Satellite West. As we went LOS, the OMS 2 burn was in progress and looking good, and we should have confirmation of the completion of that burn when we talk to the crew again. This is Mission Control.
Discovery Houston, back with you on the West Tidris. We see a good burn down here, 331 by 311. And your ohms configuration looks good.
Okay, we concur with that. We held off the gimbal check until we got back with you. We're ready to start that now.
Roger that, Lauren. We're standing by. You have a go for the gimbal check.
This is Mission Control. The propulsion systems officer reported a good ohms 2 burn and good post-burn configuration. Flight dynamics officer shows that Discovery's orbit is now 331 by 311 nautical miles, and the flight dynamics officer described that as looking super. This is Mission Control. The crew is proceeding now into the post-insertion timeline, and we'll be coming up here in a few minutes on the reconfiguration of the data processing system. The general purpose computers will be taken over to the Ops 2 software. That's for on-orbit operations. This is Mission Control. The Data Processing Systems Officer has reported that he sees the crew working the procedures for the reconfiguration of the data processing system, taking the general purpose computers over to the on-orbit software that's called OPS2. And the MAX officer reports that he sees the mission specialist crew members in the procedures to configure the aft control station at the rear of the flight deck of Discovery.
Discovery Houston, just to let you know we're still here. We see an OPS2 and looking good.
Roger that, Steve.
Discovery Houston, the Teeter State Vector's on the way to you for the SM machine.
Roger that, Oz. Houston Discovery, we're ready for airlog resets with your concurrence.
Roger that. Discovery, you have a go for airlog reset.
Roger that.
This is Mission Control. The Guidance, Navigation, and Control Officer reports that they see Discovery moving to the payload bay door opening attitude.
Go ahead, Discovery.
Roger, we got the payload bay lights on, and first glimpse, the Space Telescope looks like it's in great shape.
Okay, Bruce, roger that. Thank you. Discovery Houston, TDRS is moving off the nose. Comm may be marginal here for a few minutes.
Roger that, Steve.
Discovery Houston, you have a go to open payload bay doors.
Okay, Steve, we copy go for payload bay door opening.
Discovery Houston, I'd like you to hold on opening the doors here for just a minute. We'll give you a call.
Okay, Steve, we copy, and we'll do that. We're not quite in the attitude yet anyway.
This is Mission Control. Everything going so well with all the systems aboard Discovery. Got a little ahead of ourselves in flight control and gave the crew the okay for payload bay door opening before they had completed the last few degrees of their maneuver to the attitude for payload bay door opening. So they'll be completing that maneuver and then opening the payload bay doors.
I'd like to welcome you to our STS 31 post-launch news conference. Our players from your left are KSC Launch Director Bob Seek and George T. Sassine, Director of Shuttle Engineering. We'll start off with Mr. Seek.
Well, we're obviously pleased to be here after a long effort to get the Hubble, the shuttle, into orbit, and that was accomplished today through the work of a lot of people. The countdown process since yesterday really went well. We were concerned about the weather early on. The severe weather which we thought might impact us stayed away, and the launch conditions and the landing conditions were all acceptable when we went into terminal count. And we really had very few problems. We stayed on the timeline all night. We did send a crew into the launch pad to verify the setting of some circuit breakers on the ground system, but we ingressed the crew on time, went right into terminal count, had one what would appear to be funny or glitch on a computer display, which was an explained condition due to the computer timing at that moment, and went into terminal count ready to go on time. As you know, we stopped at 31 seconds, which again is a reminder of the complexity of the system, but also that the systems work whenever all the prerequisites are not satisfied, and we stop and we hold and we evaluate the condition, and if we can fix it, we continue on. If not, we don't launch. Well, today we were able to fix it. The software sensed that a valve was not in the right position, which it was not because the command hadn't gotten through. The engineers responsible for that system backed up the command, positioned the valve correctly, verified that everything else in their system was in the proper configuration, and we picked up the count and launched safely and successfully. And I think that's a testimony to the way the system should work, the hardware, the software, and the people, and it all has to be right before we commit to launch, and that was done to everyone's satisfaction today. So we feel good about that. We feel good about the hardware that we put on orbit, and we're looking forward to the results.
Ted? I had hoped to be able to come over here today and tell you absolutely nothing about a totally boring, perfect launch count. I almost made it. And it was really a very routine count. Everything worked beautifully. The problem that got us in the dying minutes, I will see if I can explain without making it too complicated. About 12 years ago or so, when the liquid oxygen system was in its infancy and people were thinking about it, they worried about closing the fill and drain valves, which are fairly good sized valves, against any sort of pressure. So we built a little set of logic in the software called prerequisite logic, and it looks at 3 or 4 things and says all these got to be right before you can do something. And that's what was looking at the LOX outboard fill and drain valve when this happened. About 3 weeks ago, another event caught up to us. We had an old rusty water pipe in one of the outbuildings that sprayed on a motor control assembly that had 4,000 volts in it. Well, the explosion caused a pretty good ringing on the buses around here, and it took down an LPS control room in about 2 cycles. So we had a whole bunch of what-if meetings, as anybody would do, and said, what are you going to do if this catches you at the very wrong time? And the liquid oxygen people made it loud and clear. If we can't drain within 9 minutes of stopping flow, the system will do what is called geysering. And I'm sure you're all familiar with geysers and how they work. And that will destroy the tank. The only other choice you would have to do then without LPS is open this valve and dump that head of LOX into an absolutely empty pipe. Now, you're all familiar with water hammer in your houses. LOX is heavier than water. And we have a great big filter, and we could undoubtedly rupture some plumbing if we did that. So the fix was to put a purge in that line and put a small gas pad in there. And we did that by hand after the inboard valve was closed and before the outboard valve was closed. The ground launch sequencer sent its closed outboard command at 48 seconds. The LOX console says you don't meet my prerequisite because you have this purge valve open. And so it said don't close. Long ago, we had ceased to worry about closing that valve against purge pressure, but we had never really fixed the software because it never bothered us before. And I guess this time we violated one of our own cardinal rules that says never ever make a software change unless you can run it many, many times. And we keep getting reminded that this is the most complicated toy ever built by mankind. And all the complication doesn't fly, half of it stays here on Earth. So anyway, to reaffirm Bob's point, though, the software would have safed us completely. Of course, we wouldn't have launched. So we're going back again and carefully review some cardinal rules and carefully review why we're never going to deviate from them again. That's really about all I got to tell you about it. It was about 10 seconds after it happened, everybody looked around and said, oh boy, were we dumb. And they knew exactly what to do, and they did it. That's kind of our story. I think the launch was beautiful. I hope the mission will be an equal success, because to me, this is probably the shuttle program's most significant mission. I'm a real enthusiast of the Hubble Space Telescope. That's really all I have to tell you. I'm sorry it wasn't more boring.
We can take questions at this time. Please wait for the mic and give your name and affiliation. Dan?
Dan Billow, WESH-TV. So, George, did you have to fix something, or did you have to just realize, oh, it's okay, let's tell it that it doesn't need to do anything?
We simply bypassed the prerequisite step in the logic and sent the close command. We didn't have to fix anything.
Harry? 1 second, please.
Harry Colcom, Aviation Week. Ted, how did you send it? What method did you use? Did you manually bypass the computer or what?
No. Our launch processing computerized system has a bunch of ways you can manually send commands. It is not a switch with a wire. The guy puts his cursor on the valve and presses the button, says enter, and the cursor sends the command through the computer system.
Phil?
Okay. Philip Chen for Astronomy. Bob, we've seen the shuttle as a fantastic machine, but also as a machine where everything has to be working 100% every time at liftoff. You have to have all 3 APUs operational in both high and low speed modes, and every other system has to be operational. Can we get to the stage when we're like an aircraft, where we have a list of things which aren't as necessary, or where we have redundancies, so we can only need, say, 2 out of 3 APUs operational?
I don't think you'll ever see the program to the point where we will give up our redundancy on the ground where it has to do with a critical system like APUs, main propulsion, and life support systems. The redundancy is built into the vehicle. It was designed that way to be used on orbit to complete the mission and to land safely. And our approach to that is we're going to save it for that, and we're going to make it 100% before it leaves the ground. And I think the record shows that when we have stopped, scrubbed, or terminated the launch count, it's for those reasons that you did not want to launch that day.
We'll take one more question here before moving to Houston. Dan?
Yes, Bob, when were you or was the test director notified that this system was not closed, and was that the proper time to have been notified, or should you have known minutes before that it wasn't closed?
No, the command doesn't get sent until within -1 minute, and when the command didn't get through, we all got instantaneous notification that it didn't make it. And of course, we have the built-in hold point at 31 seconds to work the problem, and that part of the system all worked. Is what Ted said was if there's any deficiency in a training simulation sometime back in the flow prior to going into launch countdown, this would have been the time to catch it, so we wouldn't have had hold in our launch count.
Do we have a question at JSC?
Okay, this is Johnson Space Center. John Getter. John Getter, KHOU-TV. For George, if I understood you correctly there, you were saying that essentially you got caught because you violated some of your own practices and rules and explained why they're so important. I'd like to ask you a question we've asked astronauts and others periodically, and that is, are you at all concerned that there is any kind of a tendency developing to start skirting any of those rules, bending them, or trying to get around them when they're not convenient?
Well, the first answer is a direct no. That tendency has not been apparent. The rule we actually violated was one of sufficient magnitude of testing to catch the problem. When you make a software change, as the folks in Houston will tell you, you must run this many, many times because there are oddities about software changes that you don't always get the first time through. And the basic rule we violated is we did not test it enough. And we're going to go back and reaffirm how much it actually takes before you can do something like this. But no, there has not been a laxity here about relaxing those kind of rules. Maybe the rule was not quite stringent enough to begin with.
Do we have any additional questions from JSC?
That's all the questions from JSC.
Coming back to KSC, Jim.
Jim Banky, Florida Today. Bob or Ted, could either of you review some of the other problems that occupied your attention before you got to this T-31 and talk a little bit about the ice and this plug and whatnot that was going on?
Well, I can address the ice issue, and in all our launch count procedures, we do a visual ice inspection remotely with television and hands-on crew, and the criteria is essentially no ice that could potentially impact the orbiter in the sensitive critical tile areas. What was different in this launch count, we noticed a little larger buildup of ice on the hydrogen umbilical between the orbiter and the tank. We always see some ice there. If it is of the nature that it's soft or it's mostly frost, then we just, we essentially ignore it from the standpoint of being a threat. This time there was more of it out there, so it attracted more attention. We suspect that the ice and the frost, probably more like slush, was building up due to a leak around a closeout plug that is inserted in the insulative foam because that's an access area for a ground checkout tool. And the plug was put in, and in the first tank cycle, we saw very little ice around there, so we felt the plug was holding good. Obviously, the cold shock, as it were, on that line opened up some gaps around the plug, and we got more ice this time. So the discussion was, do we have too much ice? Would it be an unsafe condition? The answer to that was no. And secondly, would we be concerned about the plug coming out? And the answer to that was no. But that's why that's why it took up. It had the management involvement routine, as it were, in launch count, and that's the only one, as Ted would characterize the launch count from the standpoint of training and non-standard work. It was uneventful.
Paul?
Paul Hoverston, USA Today. Question for Ted. You've got Columbia sitting out on the pad, and do you expect to have enough of these software tests run before you launch that one, or you're going to be cutting it close, or what's going to happen?
I may just pull this procedure if there isn't time. The procedure was a response to what I would call almost a non-problem. The power system around this place is pretty well built, and we rarely blow up 4,000 kVA motor control assemblies. Most of the time, our uninterruptible power system saves us. This time it had some extra positive ringing, and half our units are 10 years old, and they just didn't protect. I really don't think it's prudent to put a lot of effort into planning for a total LPS loss between 31 seconds and T0. And I think if we look at this procedure, we'll just probably pull it for now until we can put the proper testing on it.
Beth?
Beth Dickey with Reuters. Ted, I'm just a little unclear on why it is this software change was not tested enough. Is that because your rules don't require a certain number of tests, or were you trying to save time?
And I guess the answer to both of them has to be yes. We probably have not specifically specified the number of tests, I know we have a certain amount we run, but maybe we ought to say there ought to be more. And it was a little late in the game when all this happened. And really, all of those experts who should have been smart enough just weren't. Still want to emphasize, the software safed the system like it's supposed to. You can't make it unsafe. And the only thing would have happened, we wouldn't have launched. No.
Gentleman in the back row.
Kevin Dunn from NBC News. I'm a little mixed up. Was this purge valve on the shuttle, on the tank, or on the ground? What is the physical position of the valve that got?
I'm going to guess, but I believe it's on the ground.
It's not a problem on the shuttle now. They left it behind them.
Well, it wouldn't have been a problem anyway, no matter where it was.
I mean, it's not a sticky valve sitting up in
no.
the
It was commanded to be opened deliberately. And when it got down to the final command for the outboard fill and drain, that logic wanted to be commanded closed. Yeah, there was nothing wrong with the valve.
Do we have any additional questions?
Hi, do we know what the orbital parameters, sorry, Nick Booth from the Observer in London. Do we know what the orbital parameters are, and is there any engineering data from the mirror? How is it, what's its shape, anything like that?
We can get the orbital parameters from JSC, Nick. Do you have any additional questions? If not, that concludes this briefing. Thank you very much for coming.
Discovery Houston with a switch throw for you on L12.
Okay, go ahead, Steve. We're ready.
Roger, this step was left out of post-insertion. We'd like to go ahead and close the keel camera heater power circuit breaker on L12.
That's complete, Steve.
Roger that. We see the KU antenna deployed, dual motor times.
Roger that.
This is Mission Control at Mission Elapsed time 1 hour 44 minutes. At 1 hour 37 minutes Mission Elapsed time, Capcom Steve Oswald gave the crew their go for orbit operations. About 3 minutes before that, the mechanical systems officer reported the payload bay doors opened and everything worked normally. No problems or glitches at all. And the crew also has deployed the KU band antenna about 10 minutes early. And that antenna deployed fine with no problems. They are proceeding on through the remainder of the post-insertion timeline on time.
Houston, Discovery.
Go ahead, Discovery.
Raj, it looks like it's still a nice day down at the Cape. We can see Florida, and I bet you that if my eyes are a little better, I can see the families just about ready to take off for Houston.
Roger that, Steve. I bet you're right.
Seems like we were just there.
Yeah, they can see Pad Bravo also, and it doesn't look like it's scorched or anything.
Yeah, sure looked pretty about an hour and 46 minutes ago. Discovery Houston, we're showing the right-hand flight controller power switch on. Can you check that switch in the off position for us?
And we just completed that, Steve.
Roger that.
This is Mission Control. Controllers believe that right-hand flight controller power switch was probably inadvertently turned on as the crew left their seats to begin getting out of their partial pressure suits that they wear during the launch and entry phases. And pilot Charlie Bolden turned it back to the off position.
Discovery Houston with a switch throw on L1.
Okay, we're ready, Steve.
Roger, we'd like to take the high-load evaporator off. And you also have a go for vernier ops. And we'll be handing over to the East Hedris here in about another minute, so we may lose you just momentarily.
Okay, we copy that. High-load evap is off, and we'll go ahead and work the config for vernier op.
Okay, sounds good, Charlie. Hello, Discovery. You're loud and clear.
Okay, we just wanted to double check we had set the speaker back up.
Roger, Discovery. Charlie, you got a little bit of squeal, but other than that, you're loud and clear.
And Houston Discovery, we're ready to go ahead and start working the fuel cell oil purge with your go.
Roger, Discovery. Stand by just a second, Charlie. Discovery, Houston. Charlie, have a go for the fuel cell purge, and we'll watch it. Discovery Houston, we've lost TDRS here temporarily. We're still with you, UHF, through Dakar.
Roger, Houston.
This is Mission Control. The next television, actually the first downlink from Discovery for this mission will occur at 10:09 Central Daylight Time, and will be some payload bay views and watching the RMS power up and check out, and a visual inspection of the Hubble Space Telescope. This is Mission Control. The crew is about to wind up their procedures and activities now in the post-insertion timeline at 2 hours and 30 minutes mission elapsed time. They'll be going over to the regular flight plan for the rest of the mission. Very few problems during the ascent and early phase of the mission so far. At about 10 minutes mission elapsed time, right after main engine cutoff, propulsion officer reported reaction control system thruster L3A had failed off. So far, the propulsion people believe that that was a failed valve, although they have not determined exactly what the cause of the problem was. And the thruster is just being left off. No impact is expected. The only other two items were ECOM officer reported supply water tanks C and D had not equalized. Tank C is at 99% and tank D is at 89%, and usually by about 45 minutes mission elapsed time we see both of those tanks equalized. They're not clear yet why those two supply water tanks don't have an exact equal amount in them, and they're still looking at that. No action is required right now. No impact at the present time, and as soon as the environmental systems people have more information or an answer, we'll pass that along. The propulsion officer at about an hour and a half into the mission reported a pressure alarm message on the left OMS, or orbital maneuvering system, oxygen tank. That tank has a transducer that prior to liftoff was already biased high by about 8 degrees. They believe that the alarm message was caused by what they call soak back of heat following the orbital maneuvering system's 2 burn. And propulsion officer continues to watch that, and they hope that just with time that system will just cool down on its own and not require any further action. No impact is expected. The limits on that alarm can be adjusted if necessary to prevent the alarm.
LOS on the East Hedris here in about 13 minutes. We'd like to try to get the KU self-test completed before we lose you on this side. So if you could go ahead and get into the KU band activation procedure on 2-5 of the Orbit Ops checklist, we'd appreciate it.
Roger, Steve, we're into the note that says system warm-up takes 4 minutes. I've already come down through the IO reset KU block.
Roger that, Bruce. Sounds like you're ahead of us. Thanks.
This is Mission Control. That alarm transducer on the left ohms oxygen tank could be reset to higher limits if that were necessary, and we expect further analysis later on from the propulsion systems officer and his backroom support people. No other systems are having any problem. The flash evaporator system worked well. It was shut down on time, and the environmental systems officer reports seeing good radiator flow in both loops. Crew is given the go for payload bay door opening at 1 hour and 37 minutes, and they are well into their checklist now. Right now in the process of powering up the KU band antenna system. This is Mission Control.
Okay, Steve, I've initiated self-test.
Roger that, Bruce. Thank you.
This is Mission Control at mission elapsed time 2 hours 22 minutes. Our next television event will be downlink from Discovery, payload bay views, visual inspection of the Hubble Space Telescope, and watching the power up and check out of the remote manipulator system, the robotic arm that will be used on flight day 2 to deploy Hubble.
Looks like self-test is complete at 2 plus 22 plus 40, over.
Discovery Houston, Roger Bruce, thank you.
That downlink television will take place at 10:09 a.m. Central Daylight Time. In the mission control room, the Orbit 2 flight control team has arrived and is in process of getting their handover from the Ascent flight control team. Orbit 2 team will be taking over control of the mission sometime in the next 30 minutes or so. This is Mission Control.
Discovery Houston on your left ohms.
Roger, go ahead.
Roger, we're watching that left ohms tank P creeping up. It's just about to ring the hardware caution and warning. We'd like to go ahead and reset the high limit on the hardware caution and warning. That's channel 7. We'd like to go from 3.6 volts to 3.65 volts for channel 7.
Okay, Steve, you were cutting in and out. We need to have you repeat that.
Roger, Lauren. The hardware caution and warning for the ohms tank P, we'd like to raise the upper limit. That's channel 7. We'd like 3.65 volts for channel 7 on the high limit.
Okay, we understand for left ohms tank P, hardware CNW upper limit changed to 3.65.
That's correct, and that's channel 7, Lauren.
You bet.
Discovery Houston, we're going to lose you in about a minute on the East Hedris. We'll see you on the west side at 2+33. And if you can, we'd like you to go ahead and get into the cap, and you have a go to start the maneuver to IMU align attitude when you can do it.
Roger that, thank you.
This is Mission Control. We'll reacquire voice and data with the crew in about 3 minutes on the Tracking Data Relay Satellite East. Just before this loss of signal period, the propulsion officer recommended that the crew reset the caution and warning alarm limits on that left ohms tank, oxygen tank pressure. It was reaching the alarm limit and was going to give a nuisance alarm. Still not a definite understanding of what's making that alarm go off, although it does have a transducer that's biased about 8 degrees high. Continuing to watch that and do not expect any impact to the mission from that condition. The payload deploy and retrieval system folks who monitor the manipulator arm aboard Discovery report that the crew has begun the configuration for the RMS checkout coming up in a few minutes. We're expecting a downlink television beginning at 10:09 a.m. Central Time. That should show us some payload bay views and visual inspection of the Hubble Space Telescope, as well as watching the RMS power up and checkout activities. This is Mission Control.
Discovery Houston, back with you through Tidris West.
Loud and clear, Houston.
Roger that. We read you the same, Lauren. And just a status for you on L3A. They've looked at that jet, and the data says that the ox injector valve did not open for L3A. So we're considering that that jet is lost for the remainder of the mission. And that costs us the 4-jet plus X deorbit capability. However, we will have 3 plus X jets available for any on-orbit maneuvering.
Okay, we copy that.
Discovery Houston, the ascent team has completed the handover to Orbit 2. We enjoyed working with you guys to get you on orbit. It was a beautiful launch. Best of luck to you tomorrow on getting HST deployed. The majority of the folks will be back with you tomorrow. The rest of us will join you for STS check-out. We'll see you later.
We thank you very much, Steve, and it went very well. Thank everybody for us.
Roger, we'll do that, Lauren, and turning you over to Jim Boss.
Roger.
ahead, Discovery.
Roger, KU band comm activation is complete. The tags are still warming up. I'll give you a call when it's ready to go.
Roger, we copied, Bruce.
The flight of Discovery and STS-31. The Orbit 2 team now on station here in the control center under the direction of Flight Director Milt Heflin. We're presently standing by to begin the power-up of the remote manipulator system arm. To do that checkout, the arm will be used to release the Hubble Space Telescope tomorrow afternoon. We are presently standing by also to take some views from Discovery's payload bay, and those views will be upcoming momentarily.
And Houston Discovery, have you been watching all the INU line?
Discovery, Houston. We have all the IMU data we need. Looks good.
This is Mission Control. The PDRS officer reports that the remote manipulator system arm has been powered up and the uncradle is in progress. Discovery now crossing the equator, beginning orbit 3, now at an apogee of 331 nautical miles by a perigee of 310 nautical miles. The orbital period of Discovery currently is 96 minutes 44 seconds.
Discovery Houston, we were off the tail for just a little while. We're back with you now, and I have a switch for you on L1 when you're ready.
Go ahead.
Yeah, Lauren, we'd like for you to take the flash evaporator controller Pry A off and Bravo on. We've seen tanks Charlie and Delta, supply water tanks Charlie and Delta, not equalizing, and we'd like to use some water to troubleshoot that. We see about a 10% delta right now, and 3 to 5% is nominal, so we'd like to use controller Bravo for a while and see if we can get some water out of tanks Charlie and Delta.
Okay, we'll turn A off and B on.
Okay, and we'll let you know if we find out anything from this.
Roger.
And while we're having a little comm trouble with being off the tail, I don't know if you heard, but we do have the IMU data.
That's where we heard you say that.
Discovery Houston, earlier while we were listening to some communications checks with you, we did not hear UHF comm from the commander or from the MS station. We're wondering if those stations have UHF turned off or if we have a problem. Could you help us out with that?
Well, Jim, we show air-to-air on all 3 of those ATUs.
Okay, Lauren, when we come up on Vandenberg in just a couple of minutes, we'd like to make a radio check with you to check out the UHF comm from those stations. We'll give you a call when we get Vandenberg UHF.
Roger.
And this is Mission Control Houston at 3 hours 2 minutes into the flight of Discovery. We're now seeing payload bay views from camera A. That's on the forward bulkhead of Discovery looking aft. We're seeing the remote manipulator system arm as it is put through its paces being checked out for tomorrow's activities related to the Hubble Space Telescope.
Yep. Discovery Houston, we're getting some real good payload bay television downlink, and we see that Steve has been hard at work getting the RMS deployed.
Okay, he's getting a good start into RMS checkout right now.
Roger, Lauren.
And this is Mission Control. We're now looking forward from the aft camera C, that's on the right-hand side of Discovery, looking forward at the KU band antenna. That antenna is used to downlink television pictures, as we're seeing now, and voice commands from the crew to the ground. And as the RMS checkout is in progress, so too is the beginning of the pre-breathe activities related to depressing the cabin from 14.7 psi down to the 10.2 psi level, where the crew members will stay through HST deploy activities. Go ahead.
This is Hubble Telescope Control Greenbelt. As we're getting our first television from the spacecraft, this is the first opportunity for control team members here in Greenbelt, as well as analysts in Huntsville, to survey the telescope post-launch. This view is of the aft end of the aft shroud of the telescope. The aft shroud houses the scientific instruments, and we're looking forward on what would be actually, when the telescope is deployed, the port side of the telescope, but it's the starboard side of the orbiter, as the telescope is situated on its back, so to speak, in the payload bay, the aperture end toward the front of the cargo bay, and the instruments toward the aft.
And this is Mission Control. The PDRS officer reports that Mission Specialist Steve Hawley is in step 3 of the RMS checkout. That is the backup drive test. Everything continuing to go smoothly in that realm. We will be losing television here shortly as we go through the ground station. We will have a normal handover from the Tracking Data Relay Satellite West to the Eastern Satellite on this orbit.
Discovery, Houston.
Go ahead, Jim.
Yeah, Lauren, we're over Vandenberg now. We have UHF. We'd like for you to do a comm check off of each of your ATUs if you would, and you can leave them up, all of them. We'll just listen to UHF and see if we get you.
Okay, stand by.
Houston Discovery.
Okay, Discovery, Houston, we heard you only on air-to-ground 1 on that one.
Houston Discovery, radio check through the MS station.
And we heard you loud and clear, Discovery. And Discovery, Houston, correction, that was air-to-ground 1. We had no UHF on that MS station.
Okay, Jim, we have double-checked the config and everything, and let us go to another station and give you a call. Stand by.
Okay, Charlie, we'll be waiting.
Houston Discovery.
Discovery, Houston, we hear you on air-to-ground 1, but again, no UHF.
Roger, on the tags activation, I've got an over-temp light which came on and then it went off for a minute or so, and now it's back on. Looking at the malfunction procedures 2.8 Bravo, it indicates probable noise and heater ring assembly and MCC will perform ground malfunction. Over.
Okay, Bruce, we copied that and we have that in work.
Okay, and I still have not advanced the paper necessary to feed the exposed paper out. I did advance about 4 sheets initially and it all came through fine, but I haven't done anything since then.
We copied that.
Houston Discovery.
Go ahead, Discovery.
Roger, here's one more comm check. This is still on the A11 CCU, and that's the MS station. How do you read?
Discovery Houston, we had UHF for just a second when you called that time, but then nothing later.
Roger that. Let me try another station.
Okay, and just let us know what station you're at.
Houston Discovery, I'm plugged into the PLT's R6 panel now, and his ATU has air-to-air in the TR position. How do you read?
Discovery Houston, we have no UHF.
Roger that, and let me check the CDR's panel.
And Discovery Houston, we had UHF that time, Lauren, but it was pretty garbled.
Roger, how about now?
We hear you again, but there's an echo and it's garbled.
And Houston Discovery from the CDR panel, air-to-air is in TR. How do you read?
Discovery Houston, again, no UHF.
Okay, we copy no UHF that time either.
And Lauren, that time we did get some UHF.
Okay, well, I'm not sure what we're doing any differently. This is still the CDR's ATU. Unless you think it could be something in the speaker mic unit that we're using.
Yeah, Lauren, we're not sure. We're going to continue to look at it. We had your UHF just a minute ago, and then the last time you spoke, there was no UHF. Discovery Houston, Lauren, we'd like for you to go to the commander station and then switch to Audio Center 2 and make a radio check with us there.
And Houston Discovery on Audio Center 2 from the CDR ATU. How
heard you that time, Lauren, but it was a bit garbled as it was before.
Roger, we're reading you loud and clear.
Okay, Lauren. We get the UHF off and on. We're going to continue to look at it, and we'll get back with you later on.
Roger that.
Good morning. This is the Good morning. This is the change of shift briefing with our off-going Ascent Flight Director Ron Dittemore. He'll describe the events of this morning's ascent and give us a brief status on the mission. Ron?
Thanks, Billy. Really, there's not much to say. The ascent went very uneventful for us. The pre-launch work, smooth countdown as far as we're concerned, and I know you've talked a little bit to the folks down at KSC concerning the little glitch we had at T-minus 31 seconds. Here at JSC, that didn't affect us too much. As soon as they got that valve closed, the outboard fill and drain, we were all set to go, and after that it was very nominal as far as ascent was concerned. The only anomaly that we experienced really was at post-MECO, post-ETSEP. We have a procedure where we do a 4+X burn to give us some ullage acceleration for the MPS dump. And we had one +X jet, 1 out of 4, that had a failure and it failed off, and that it did not fire at all. And we have seen this type of anomaly in past flights, recognize the signature, and we think that jet has failed off and will not be available for us the rest of the flight. And as far as an impact, that jet being failed, it really is none. So we're not working too hard other than to understand what the failure was and to understand that, or look at our procedures to make sure that we tell the crew if there's any thing that we need to do to account for it. But at this point, we think there is none. We're sitting right now in an orbit that is 331 by 311 nautical miles. Looking forward to do a raised orbit burn at 7 hours 11 minutes MET. Other than that, that's really all I had to say. It was very well done, and as far as the ascent is concerned, the crew's having a good time, and they have a busy day in front of them today.
Thank you, Ron. We'll take questions here at JSC first, if we have any. Okay, no questions at JSC. Questions at any other centers? Okay, no other questions at any of the other centers. Thank you very much, Ron. That'll wrap up the briefing.
This is Mission Control. The PDRS officer reports that the RMS checkout is still continuing to go smoothly. The crew has completed the direct drive test and the hand controller check, and is now in the manual augmented modes check, and that is step 7. A few moments ago, they did the crew and the ground did a check through to try and check on the UHF circuit, air to ground, and that circuit apparently is malfunctioning, and the INCO officer continues to troubleshoot that. We will try again to communicate through the UHF when the crew comes around again on orbit 4 as we travel through the Vandenberg ground station.
Discovery Houston for Charlie. Charlie, we've been seeing the boiler controller or steam vent heater number 2 has remained off scale low. And when you shut down your boiler power on your APUs, we'd like for you to leave boiler controller heater number 2 on, and we'd like for you to take it to Bravo. And we want to get about an hour and a half on the Bravo side, the Bravo heaters, to make sure that we bake those out.
Okay, Jim, I understood the first part of it. Would you just give me the instruction for where you want me to take the boiler controller heater switches?
Roger. We would like for you to power off the boiler controllers 1 and 3 and take boiler controller heater number 2 to Bravo.
Okay, I copy. And you want those done now?
You can do the ones that are going off on time.
Okay, I'll do the ones going off on time. Boiler controller number 2 is going to Bravo.
Okay, Charlie, thanks, and we'll let you know if this one works.
And this is Mission Control Houston. We're now on the eastern satellite taking payload bay views from camera A as the remote manipulator system arm goes through its checkout. That conversation between Capcom Jim Voss and pilot Charlie Bolden was related to the water spray boilers. Those boilers, the steam vent heaters on those boilers are powered on and are allowed to heat up. Two of those heaters, or 2 of those water spray boilers heaters came up. Nominally, the third, which is water spray boiler 2, still a little off scale low, so they asked Charlie to take water spray boiler 2 to the B heaters and allow that to remain on, as the flight plan calls for all 3 to be turned off at 3 hours 40 minutes. However, only 1 and 3 will be powered off. 2 will be left on the B heater side. And this is Mission Control. We're now looking from Payload Bay Camera B straight up at the end effector of the remote manipulator system arm as the end effector goes through its checkout. The end effector will be used to grapple the Hubble Space Telescope tomorrow, and will be used to release the telescope. And the end effector is about 13 inches in diameter.
Discovery Houston, just wanted to let you know that we are getting ready to Timbu up your software limits for the 10-2 atmosphere per your checklist, page 6-3 for the EVA ops.
Okay, Tim, we copy about the 10-2 Timbu.
This is Mission Control. Mission Specialist Steve Hawley continuing to take the RMS through its checkout procedures. We are looking at the end effector as it is run through the snare drive test.
Houston, Discovery.
Go ahead, Discovery.
Roger, Jim. We think RMS checkout is complete, and we think the arm is full up. We didn't see any anomalies at all.
That sounds great, Steve, and we concur.
And this is Mission Control at 3 hours 50
and it
minutes.
looks like we'll be getting around to starting the inspection just about the time it gets to be dark.
Okay, sounds okay to us, though. I guess you can do your best. Steve, we think you got 15 minutes if you can get started on it.
Yeah, you bet. We'll do what we can before sunset.
Mission Specialist Steve Hawley reports the RMS checkout is complete with no problems, and the Mechanical Systems Officer reports the same.
Discovery, Houston, it looks like your steam vent heater number 2, Bravo, is working fine. We'll leave that on for about an hour and a half to get the water out of the lines.
Okay, copy, Jim, and let me make sure I understand what you wanted me to do on this steam vent heater deact. You just want boiler power off, is that correct?
Yeah, Charlie, we need to leave boiler power number 2 on, so just take boiler powers 1 and 3 off and leave 2 on so that we can have that Bravo heater.
Okay, Jim, you were cut out. Say again.
Okay, Charlie, we would like for you to leave steam boiler. Discovery, Houston, we think we've got a good forward link. Our downlink may not be good. What I was telling you, Charlie, was we want you to leave steam vent heater 2 Bravo working. So leave boiler power 2 on Bravo and boiler powers 1 and 3 off.
Okay, that answers the question, and we're doing that right now.
And this is Mission Control. Some more good news in addition to the RMS checkout going smoothly. Water spray boiler 2 heater on the B side is working properly. They are, however, going to leave that on for about 90 minutes to take a look at that. Water spray boilers 1 and 3 have been turned off. And Mission Specialist Steve Hawley is beginning preparations to do a a inspection of the Hubble Space Telescope. Hopefully he will get into that before Discovery moves into darkness.
This is Hubble Telescope Control Greenbelt. Next television scheduled on NASA Select is an orientation of the Space Telescope Operations Control Center here at the Goddard Space Flight Center in Maryland. That's scheduled to occur approximately 4 hours, 12 minutes mission elapsed time, 11:46 Central Time, 12:46 Eastern. This is Hubble Telescope Control Greenbelt.
Houston, Roger. We're getting the cabin press messages. The cabin free breeze.
Discovery Houston, your dropping in and out right now, but we understand your cabin pressure message and no action required.
Roger that.
Discovery Houston for Charlie, your APU cool-off that's called out at 4 hours in your flight plan, we'd like to delay that for a little while, and we'll get back with you later when we want you to do the APU cool-off.
Okay, we'll note that.
Discovery Houston, watching the 10-2 prep, on panel L1 it called out water loop 2 bypass manual decrease for 30 seconds. We're wondering if you did that step, and if you have not, if you would do that one.
that far yet, Jim.
Okay, Lauren, thanks.
Houston, Discovery.
Go ahead, Discovery.
Okay, Jim, we think we've completed all the 10-2, and you guys have tempoed the SM CNW changes as we understand it, so I think we're ready for the debrief on page 6-4.
Yeah, Charlie, we'll give you a go on that in just a minute. In the meantime, just a status update on your supply water tanks. They're looking good now. We believe that may have been a stuck bellows, and it seems to be working all right, and we'll continue to watch it, though.
Okay, we copy. And we're going to go ahead and start working our hardware caution and warning ahead of time here.
And Discovery Houston, we are happy with everything you've done. Looks like you're ready to continue on with your depress. We're going to be LOS in about a minute or so. We'll be back with you on the other side at 4:16.
Okay, we copy 416. It's going to take us just a few more minutes while I get the hardware CNW.
Okay, that sounds fine. We'd probably like to watch that anyway. Discovery Houston, we're back with you on TDRS West.
Clear.
And we hear you loud and clear, Lauren. Discovery Houston, we're getting good TV downlink of your survey now, and I have some switches for you to check on panel A7 when you're ready.
Okay, go ahead.
We've been seeing some problems with the MADS recorder. We'd like you to check the configuration. On panel A7L, if you would, check the following switches. MADS recorder power to PCM/WB enable. PB forward to command. Strain gauge on. Wideband/ASIP PCM to command. PCM to command. PCM record mode to sample. FDM control to data, and the ASIP heater to off.
Okay, Houston, we moved two switches. We moved the MADS recorder power to the PCM/WB enable position. It was OFF, and I think the other one was strain gauge PCM enable on switch. We took it to the ON position.
Okay, Steve, thanks. That may have fixed our problem. We'll let you know if we have any future problems.
Okay, Jim, if you guys are ready, we're ready to start the depress, and we show ourselves actually on the right-hand side of the approach zone, so we're ready to go if you're ready.
Roger, Charlie, we concur, and your go to begin your depress.
This is Mission Control Houston at 4 hours 22 minutes. The crew's been given the go to begin the
And Bruce, you can take the airlock depress valve as soon as she's complete with that to 5.
The crew's been given a go to depress the cabin from the 14.7 psi level to the 10.2 level, as we are seeing payload bay views from the remote manipulator system arm as mission specialist Steve Hawley does a photo survey of the Hubble Space Telescope.
Houston, Discovery, triple mode.
Go ahead, Discovery.
Roger, Bruce and Kathy are still on the HRA and doing the PI config on page 1-3 of the deploy checklist. We did not get a asterisk by PSP enable item 1 on spec 225.
Okay, Lauren, we copied. We'll get back with you.
This is Hubble Telescope Control Greenbelt. As we go through the survey of the Hubble telescope, the crew has been scanning across the optical telescope equipment section of the vehicle, which is situated just forward of the subsystems module equipment section. These compartments contain electronics for several of the optical telescope assembly components. Additionally, Director of Orbital Verification, Mike Harrington, has advised Mission Control's Payload Officer, Jeff Henley, that the Space Telescope Operations Control Center is ready for the activation of the main power bus by the crew, which is scheduled to happen here shortly. Television now being received from the spacecraft has been showing the 8-foot wide solar array in its stowed configuration.
Discovery, Houston, about your question about the asterisk on spec 225, we believe that that's an error in your checklist. For PSP enable 1 ID, you should have a 1 rather than an asterisk there.
Okay, thank you. We do have an ID 1.
Okay, Lauren, and we see you in a good configuration now.
Roger.
now in the field of view one of the two grapple fixtures mounted to the Hubble Space Telescope. One of these fixtures will be used by Steve Hawley tomorrow to grapple the telescope with the remote manipulator system to lift it out of the payload bay.
Discovery Houston for Bruce. We believe that the tag's overtemp was a false indication. We've run through that now. It's back on, and you're go to continue running some paper out of it and complete the activation.
Okay. I'll get to it in just a minute. I'll call you back when I'm through.
Roger.
And this is Mission Control Houston. All operators are go to allow or tell the crew that we're ready to transfer the main bus activation to the Hubble Space Telescope. We will be standing by shortly for that call to the crew.
Discovery Houston, just wanted to let you know that the ground is currently configured for HST main bus activation. So we're ready when you are.
Okay, we copy, Jim, and we'll give you a call when we get there.
Okay, thanks, Charlie.
Are you guys seeing TV?
That's affirmative. We're still continuing to watch your inspection.
And Steve wants to know if there's anything else that you'd like to see that he hasn't shown you.
Okay, we'll check with our payloads folks and we'll see. Did you see anything visually that we didn't see?
As far as we've been able to see on board, everything looks perfect.
Okay, thanks. We'll get back with you if we need anything else.
And this is Mission Control Houston. That call was to notify the crew that the ground is configured for activation of HST main bus. Also, the crew reports that HST during the visual inspection looks great. No unforeseen items of interest at all. So far, everything going very smoothly in the visual inspection of the telescope.
And Houston, Discovery.
Go ahead, Discovery.
I think we're ready to get into the main bus activation now.
Okay, we're ready for you to do that, Lauren.
Listen on my mark, main bus external power is coming on. Stand by. Mark.
And Houston, we just put the main bus power on.
Roger, Lauren. We copy.
This is Mission Control at 4 hours 43 minutes, mission elapsed time. The crew confirms and the ground concurs that the main bus power to the HST is activated.
This is telescope control in Greenbelt, with the electrical power now being provided by the orbiter to the telescope's 3 main buses. The orbital verification team is preparing to send a series of commands in the blind to establish communications with the telescope. We'll be standing by to take a look at the results of that initial transmission. While the receivers on board have been on since about 3 hours before launch, its transmitters have been powered down. This initial series of commands will configure one of the telescope's 2 multi-axis transmitters through the orbiter's payload interrogator.
We see you at 10.2, and we're ready to Timbu up your post 10.2 limits.
completed the transfer to main bus power. We're standing by for your call to open the fixed head star tracker and turn off the RSU heater power.
We copied, and we'll get back with you in just a minute on that.
Okay.
And Discovery Houston, did you get my last on the 10-2 Timbus that we're going to send up to you?
Okay, we understand they're coming.
That's affirmative, thanks.
This is Hubble Telescope Control Greenbelt standing by for word that the initial commands have had their desired effect, which will allow telemetry to be transmitted by the telescope for the first time. And this is Hubble Telescope Control. We have acquired our first data from the Hubble telescope here in the control center. This is giving the controllers here their first opportunity to take a look at the configuration and condition of the telescope since it was powered down on Saturday.
Houston Discovery.
Go ahead, Discovery.
I tell you, the arm flies real well. I've about run out of things to look at. If you guys don't have anything else that you need me to go have a look at with the end effector camera, I'll begin RMS power down.
Roger, Steve. We don't have anything else, and your go for RMS power down.
Okay. As near as we can tell, everything looks perfect.
Well, I know we're all glad to hear that one. Thanks for the input.
This is Hubble Telescope Control Greenbelt. Analysts here and in Huntsville are now taking a very hard look at the initial data to confirm that the Hubble telescope is in the correct configuration and that nothing has changed since the launch.
Discovery Houston, we have some further troubleshooting on the UHF problem if you have someone available.
Okay, Jim, can you guys give us just a few minutes to get the 10-2 cabin press, depress cleaned up, and another few things?
Sure, Charlie. Just let us know when you're ready.
Okay, and can you, I think the only thing that I see that we might need just to look at is the 2 slipped back up on us while we were getting the HRAs turned off and everything, but I think we're okay. You guys might take a look at that. We finished the CNW and understand that you did the Timbu for the backup, and we're installing the bleed orifice now, so that should complete page 6-6, and we'll wait for any more word from you as far as the depress.
Okay, Charlie, we see that, and we see you in a real good configuration now, and we like your cabin, so you're looking good.
Okay, and I'll get right back to you. We should have somebody free in a moment to do the troubleshooting.
Okay, it's just a couple of switches and some circuit breakers to check, and then we'll want to do another comm
okay,
check.
give them to me now.
Well, we can wait. Just let us know when you're ready.
This is Hubble Telescope Control Greenbelt, 4 hours 55 minutes mission elapsed time. Shift Supervisor Dick Turcotte has just completed a poll of all positions here in the Space Telescope Operations Control Center Mission Operations Room, and all positions report that initial data from the telescope looks very good. At this time, the Mission Operations team has is in the process of completing their has completed their first sequence of commands. Next command sequence will send a series.
Houston, for information, we didn't get the Timbu up before you did your SM checkpoint initiate, so you didn't capture those limits we'd sent up. If you'd like